So this is going to be a quick Unit 3 review for all you guys having trouble out there. This is going to be 3.1 through 3.6. Quick rundowns of the rules and stuff. That's really it. So first off, we start off with 3.1, which is chain rule. When it comes to chain rule, all you're doing is taking the derivative of the outer function and then keeping the inner function the same, and then you're multiplying or you're bringing out the inner function and then multiplying it by the derivative. That's really it. So we're going to start off with some basic questions right here. So first off, we got y equals ln x cubed. So first we're going to take the derivative of the outer function, so ln, and we're going to keep the inner function the same. So it'll just be 1 over x cubed. Now we're going to take the derivative of the inner function. So this is just going to be times 3x squared, which equals 3x squared over x cubed. And then if you want to simplify, that's just 3 over x. And that's it. Pretty simple. So go on to our next question. So this is where it gets a little bit more tricky maybe for you. You might have to use the chain rule multiple times. In this case, you're going to have to. So our outer function is sine, so we're going to take the derivative of that and keep everything the same on the inside. So this is just going to be cosine of ln x to the fifth. Now we're going to take the derivative of ln x to the fifth, so we're going to multiply that. So this is just going to be 1 over x to the fifth. And then now you got to do the derivative of x to the fifth, which is just 5x to the fourth. So altogether, you're just going to get 5x to the fourth times cosine of ln x to the fifth all over x to the fifth. That's it. So now we're going to go on to a couple more questions, but this time it's going to be a table. So in this case, there's no chain rule, it's just going to be the simple product rule. If you forgot product rule, it's just f prime times g plus f times g prime. So that's all we're going to do here. So it wants us to find the derivative at 5. So we're going to do 2 times the derivative of g of 5. So that'll be 6 times h of 5, which is just 5, plus 2 times g of 5, which is just 9, times the derivative of h of 5, which is negative 4. So you're going to multiply everything together and add it all out. So this is just 12 times 5 plus 18 times negative 4. So 60 minus 72, which equals negative 8. So now we're going to go to our next question. So this table question is actually going to make you do the chain rule. In this case, it's actually quite easy, and I'll show you how. So it wants us to find the derivative of f of 4, and we have f of x equals g of x squared. So in order to find this, I'm going to write this out. So I'm going to take the derivative of this entire function. So I'm going to take the derivative of the outer function by doing the power rule. So I'm going to bring down the 2 as a coefficient and then subtract the exponent by 1. So, and then after doing that, I'm going to multiply everything by the derivative of the inner function. And then what I'm going to do is I'm going to solve for g of 4 and g prime of 4. So g of 4 is just 3. So 2 times 3 times g prime of 4, which is just negative 2. So this will just be negative 12. And then we're going to go on to another question. So this is the same process, but since there's no power rules or anything, you just got to remember the rule that if you want to find the derivative of this using the chain rule, it's going to be h prime of g of x times g prime of x. And then it wants us to find out f of 4 is again. So g of 4 is just 3, so h prime of 3 times g prime of 4. So h prime 3 is just negative 3. So negative 3 times g prime of 4, which is just negative 2. So your final answer is just going to be 6. And that's it. Alright, last question for 3.1. It wants us to find what value of x do the graphs of f and g have parallel tangents. So what it means by when the functions have parallel tangents, it just means when what value of x are the derivatives the same. So what we're going to do is we're going to set the derivatives equal to each other and then solve for x. So I'm going to find the derivative of f of x and then do that for g of x later. So we have 2e to the 3x. So again, take the derivative of the outer function. So it'll just be kept the same, because if you know that e to the x, if you take the derivative of that, it'll still be e to the x. And then we're going to take the derivative of the inner function, multiply it, the entire thing. So the derivative of 3 to the x is just 3. So we're going to multiply the entire thing by 3. So you're going to get 6e to the 3x. So that's our first derivative. And now we're going to do that for g of x, 5x cubed. So in this case, we don't need to do chain rule. It'll just be the power rule. So 5x cubed will just become 15x squared. And now we have to set the equations equal to each other. So once you do that, if you try and do this algebraically, you're going to have a little bit of trouble because these are decimals. So assuming this is a calculator question, you have to use your calculator. So you can either solve it by graphing or solving it algebraically. So I'll do both ways, and I'm going to use my calculator. So I'm going to set the equations equal to each other, and I'm going to divide both sides by 6. So when I do that, I'm going to try and isolate or get rid of the e, so I'm going to ln both sides. And now it's going to become 3x equals ln 15x squared over 6. And then I'm just going to divide both sides by 3 to get x equals ln 15x squared over 6 divided by 3. And then when I plug that into the calculator, let's see what I'll get. So I'm going to get an approximate value of negative 0.366, which is rounded. So I'm going to go back up, and as you can see, B is our answer choice. So we're going to circle that. And then if you were to do this by graphing, you're going to have to graph both of the equations, the derivatives, and then find where they intersect. And you'll still get the same answer. We're going to go to the next question. So now 3.2 is all about implicit differentiation, and I'll explain that between these two differences. So when you take the derivative of x, it's going to be different from taking the derivative of y. So taking the derivative of x is just going to be 1, and then x squared, use the power rule to take 2x. And then chain rule for this to get 5e to the 5x. So in this case, it's going to be different with y. So taking the derivative of y, it's just going to be dy over dx instead, rather than 1. And every time you take the derivative that has y in it, it's always going to have dy over dx. So you're going to use the same rules, but this time adding dy dx. So this case, it'll be 2y times dy dx. And then the same process right here. So this is going to be 5 dy over dx times e to the 5y. And that's it for implicit differentiation. So we're going to keep on going down and show some examples later on. And then we have our tangent lines. So it says right here, horizontal tangent lines exist when the slope dy dx. That just means when our derivative at a certain point just looks like a straight line, that means dy over dx is going to be 0 because it's not increasing nor decreasing, it's just straight. And then with vertical tangent lines, if our slope looks like this vertical line, it's going to be undefined because it's infinitely decreasing and increasing. So I'll draw a quick example. So if I have a parabola, let's just say vertex is at the origin, and if I want to find the horizontal tangent at a certain point, let's just say the vertex, it's going to be a slope of 0 because it's not increasing nor decreasing. So that means dy over dx equals 0. And that's it. But then what if I take the derivative of a sideways parabola and the vertex is also at the origin, and I also want to find the derivative at the origin? Well, it's just going to be a long straight line, meaning it'll be a vertical tangent or undefined. So that's how it works in this case right here. So now we're going to go on with some example questions, show how it works, and that's it. So we're going to start off with a bit of a rough question when it comes to implicit differentiation, but I'm going to guide you on how to do it. So immediately when I see this question, I see two functions, ln x and then e to the 3y. So I know I'm going to have to use the product rule to derive this equation. So I'm going to show you how to do it. So we get ln x, and we're going to take the derivative of that because we're going to use the product rule. So that's just 1 over x. We're going to keep the second function the same. So 1 over x times e to the 3y plus ln x. And then now we're going to take the derivative of e to the 3y using the chain rule. So this is just going to be 3 e to the 3y times dy over dx. Anytime we take the derivative of something with the y variable, we got to add dy over dx. And then the derivative of 2y squared is just 4y dy over dx. Once we do that, I'm going to multiply everything out, and then we're going to isolate dy over dx. So when I multiply these two functions together, it's just e to the 3y over x, and then this is just plus 3 ln x times e to the 3y times dy over dx equals 4y dy over dx. Now what I'm going to do is I'm going to move this equation, or this part, and this part together. So I'm just going to make them both negative and switch them. So that's what I'm going to do. So I'm just going to grab this, put over here, grab this, put over here, remove that, and we're going to make that minus, make this minus. Just move it a little bit closer. Oops. There you go. Alright. And now what I'm going to do is I am just going to factor out dy over dx. So now it's just going to be left with 4y minus 3 ln x times e to the 3y equals negative e to the 3y over x. And now my final step is just to divide 4y minus 3 ln x e to the 3y on both sides, so then I get dy over dx. So I'm just going to add a line right here and move all this to the other side. Let's do that. There we go. And then that will be your final answer. And then I'm just going to move this over here, set it equal to. And that's it. So this will be your final answer for this question. So the next question isn't as rough. It's definitely a lot easier, but you're still going to be using chain rule and product rule. So in this case, we're going to take the derivative of the entire equation. So we're going to use chain rule on sine of xy. So this will just be cosine xy, and then times xy. So we have two functions. We have x and then y. So we have to use the product rule. So 1 times y plus x, and then remember, derivative of y is just dy over dx. And then the derivative of 10x is just 10. So we have cosine xy plus y plus x times dy over dx equals 10. And then what I'm going to do is I'm going to subtract cosine xy and y to just isolate and try and solve for dy over dx. So you're going to get x times dy over dx equals negative cosine x. Oh, excuse me, I have to divide cosine xy and then subtract y. So instead it'll actually be x dy over dx equals 10 divided by cosine xy minus y. And then this is the same thing as 10 secant xy, because 1 over cosine is just secant. So x dy over dx equals 10 secant cosine, or just 10 secant xy minus y. And then we're going to divide the entire thing by x. And then that's our final answer for this question. So then we'll go into the next question now. So finally, we're going to focus on these two questions that have to do with finding the horizontal and vertical tangent lines. So let's do number 18 first. So we have x squared plus x plus 2y squared equals 8. And I'm going to take the derivative of that with implicit differentiation. So we're just going to be left with 2x plus 1 plus 4y dy over dx equals 0. And then what I'm going to do is I'm going to subtract the 2x and the 1, and we will get 4y dy over dx equals negative 2x minus 1. And now I'm going to divide both sides by 4y, where dy over dx equals negative 2x minus 1 over 4y. So we have our derivative, but now we got to solve for the horizontal tangent line and our vertical tangent line. So what I'm going to do is I'm going to just grab a copy of this, and to find our horizontal tangent line, that just means when our slope is 0. So set the equation to 0. Multiply both sides by 4y, because that's all we can do right now. So we just have to get rid of this. And now we're just left with negative 2x minus 1. So I'm just going to move this. And all we got to do is add 1 to both sides and divide by negative 2. So x equals negative 1/2. And then we also got to find our y. So let's do that. We calculated our x, but this does not mean the actual equation of our horizontal and vertical. So with our horizontal tangent, we're going to find the y, and then for vertical, we'll find our x. This is just to make sure that when we find our x for the horizontal tangent, we can actually find our y. So we're going to plug this in and find our actual value, our main value, which is y. So you're going to get 1/2 or negative 1/2 squared minus 1/2 plus 2y squared equals 8. And this is just going to be 1/4 minus 1/2 plus 2y squared equals 8. And then this is going to be negative 1/4 plus 2y squared equals 8. I'm going to add 1/4 to both sides. So that'll be 33/8. Divide by 2. Then I'm going to add 1/4 to both sides. So 2y squared equals 33/4. Divide by 2. Y squared equals 33/8. And then this is going to be our final y value when we take the square root. So y equals plus or minus the square root of 33/8. So that's our answer for the horizontal tangent. So this is going to be y equals plus or minus square root 33/8. So we're going to do the same process, but instead we're going to find our x. So we already have our derivative. This time we're going to set the equation equal to 0, or our denominator equal to 0. Just to save some time to solve for the vertical tangent, if you want to solve for that, it's going to be the same process, but we're going to get our x value instead. And what we want to do is set the denominator equal to 0, because a vertical line is usually going to be 0/0, or actually no, not 0/0, but a number divided by 0. So we're going to do 4y equals 0, y equals 0. So when we do that, all we're going to do is replace y with 0 and solve for x. So I'm going to do that off the side over here. So I wrote my equation down, and I'm just going to subtract negative 8 to the left side. And this isn't factorable, so I'm going to have to use the quadratic formula. So this is going to be 1 plus or minus the square root of 1 squared minus 4, 1 times negative 8, all over 2. If you forgot your quadratic formula, it's just negative b. Oh yeah, so let me put a negative right here. So negative b plus or minus the square root of b squared minus 4ac, all over 2a. So that's what I did. And this is going to be x equals. So x equals negative 1. So 1 plus 32. So negative 1 plus or minus the square root of 33, all over 2, should be our answer for x. So I'm just going to put my answer right here. And that's it. So it definitely is a bit of a process, but all we have to do is take the derivative of this equation. In that case, it's just negative 2x minus 1 over 4y. And to find a horizontal, all you got to do is set the entire equation, or just the numerator, equal to 0, solve for our x, put x back into the equation, and then you're going to get y for the horizontal tangent. And then same process, but you're solving for x for vertical. So if you want, we're going to save some time in this video. So if you want, you can try this question out yourself. Alright, so 3.3 is just the derivatives of inverse functions. And you're going to have to remember this rule. So the derivative of an inverse function is just 1 over f prime of the inverse of f of x. So if you forgot what an inverse function was, let's just say I have a regular function where it has an input of f of a, and then my output is b. Inverse function is just the opposite of that, where our output from our main function, or our original function, is going to be the input, and then it's going to output that input from the main function, if that makes sense. So like, if I have f of 2 equals 10, for example, the inverse of that is just going to be inverse of f of 10 equals 2. That's it. So this is the rule for taking the derivative of an inverse function. So you need to remember that. So for 3.3, I'm going to quickly do 2 questions, and then we will go on to 3.4. So start off with number 15, where g of x equals the square root of 8 minus 2x. Got to find the derivative of f of 4. So right here it says that the inverse of g of x equals f of x. So that's what we're going to do first. We're going to try and get f of x by taking the inverse of g of x. And we know that g of x is the same thing as like y. So I'm just going to replace g of x as y. So y equals the square root of 8 minus 2x. And in order to find the inverse, we just flip the variables. So x equals the square root of 8 minus 2y. And once I solve for y, it's just going to be x squared minus 8 equals, or over negative 2 equals y. So this right here is f of x. And that's important to know. We're going to do something like that later. Now, I'm going to find the derivative of g of x. So g prime x equals 8 minus 2x to the 1/2 power. I wrote it as an exponent because we have to use the chain rule here. So I'm going to bring down the 1/2 and then subtract 1 to the exponent. So it's going to be 1/2 times 8 minus 2x to the negative 1/2 times the derivative of the inside function, so just negative 2. So this is going to turn out to be, and then the 2's are going to cancel out. So I'm going to show you. So this is the same thing as 1 over 2 times the square root of 8 minus 2x times negative 2. And because we're multiplying by negative 2, the 2's are going to cancel out. But the equation is going to become negative. So now you're just left with 1 over negative square root of 8 minus 2x. So we have our derivative of g of x, and we have f of x. So it wants us to find f prime 4. And if we remember from our rules that we know that the inverse of the derivative of an inverse function is just f prime inverse of that main function. So we're just applying that rule here. In this case, it's just going to be 1 over g prime inverse of this x, or the main function. So here's what I'm going to do. I'm going to plug in 4 for f of x. So you get 16 minus 8 over negative 2. 16 minus 8 is just 8. 8 divided by negative 2 is just negative 4. Okay? Here's what we're going to do with this. We're going to apply our derivative rule. So what we're going to do is we're going to plug in negative 4 inside of our derivative. So let's do that. So this is going to become negative 1 over the square root of 16, which equals 1 over negative 4. Alright? So that's it. But there's one thing. Because it's simply this rule, so 1 over g prime of f of x, we did this. We did 1 over g prime of f of 4, right? Which is just 4, or negative 4, excuse me, right? And g prime of negative 4 is negative 1 over 4. So 1 over negative 1 over 4 is simply just negative 4 as our answer. Same thing here for this next question. Should be a little bit easier. So let's do that. So I'm going to find f of x again because it says at the top that the inverse of g of x is f of x. So let's do that. And let's just do that. So I'm going to do the same thing, set g of x as y, and then switch the variables. So x equals y cubed minus 7, where y equals the cube root of x plus 7. And again, that's just f of x. Now I'm going to find the derivative of g of x. Let's do that over here. So the equation was x cubed minus 7. So g prime of x equals 3x squared. That's it. So now it wants us to find f prime 20. So what we're going to do is we're going to plug in 20 into this equation. So y equals cube root of 27, which equals 3. And then what we're going to do is we're going to plug in 1 over g prime of 3. So this is going to be 3 times 3 squared, and then 3 times 9 is just 27. So 1 over g prime 3, where we know g prime 3 is 27, the answer is just going to be 1 over 27. And that's it for 3.3. So 3.4 is just the derivatives of inverse trig functions, and these are the rules that we're going to have to remember, I'm pretty sure. So if you want, you can take a picture or do whatever, don't care. So first up, the derivative of the inverse of sine is just 1 over square root of 1 minus x squared. That's the same thing with cosine, but instead it's going to be negative. And then inverse of tan, the derivative of that is just 1 over 1 plus x squared. And then when it comes to the reciprocals of those functions, what you're going to do is it's going to be x squared minus 1. And what we're going to do is add absolute value. So for cosecant, it's actually going to be negative 1 over absolute value times square root of x squared minus 1. Secant is just going to be positive. And then cotangent, same thing as the inverse of tangent, the derivative, but negative. So we're going to do some quick 2 questions or 3 or so. Alright, first question is just the inverse of cosecant x to the 6th power. And I wrote the rule right here. It's just 1 over absolute value of x times square root of x squared minus 1, and it's all negative. And we're going to solve this derivative, so let's do that. So I'm going to do negative 1 over, and then x is our argument, so it's going to be the absolute value of x to the 6th power, and then multiplied by x to the 12th power, because that is just going to be x to the 6th squared minus 1. And if you know your power rules, it's just going to be x to the 12th. And then it's actually going to be chain rule as well, because our argument is a function as well. So we got to take the derivative of our inner function and multiply it on the outside. So it's just going to be 6 to the 5th, or 6x to the 5th power, which equals negative 6x to the 5th over the absolute value of x to the 6th times square root of x to the 12th minus 1. And one final thing is we gotta make sure if we can remove the absolute value or not. So in this case, if our x was like a negative number, it's going to say negative. And then our bottom function, our absolute value, is always going to stay positive. So we can simplify this to become negative 6 over x times the square root of x to the 12th minus 1. And that's going to be your answer for the first question. Alright, next question is the inverse of tan y equals ln x. So we're going to use implicit differentiation because we have y as an argument and x. So the derivative of inverse of tan y is going to be 1 over 1 plus y squared And we have to use chain rule because y is a inner function, so it's just going to be times dy over dx. Oops. And then equals the derivative of ln x, which is 1 over x. So this is the same thing as, we're just going to keep it like this. And what we're going to do is divide both sides by 1 over 1 plus y squared. So basically just multiply both sides by 1 plus y squared over 1. And that means dy over dx equals 1 plus y squared over x. And as you can see, we have an answer choice, which is E. Finally, we have the inverse of cosine x squared all to the 5th power, and it wants us to find the derivative of this question. So, gotta use chain rule for this because we got multiple inner and outer functions. So our outer function, we're just gonna have to apply power rule. So 5 times, and instead of arc cos, just remember arc, if it has arc, then it's inverse of the trig function. So I'm just going to do cosine to the negative 1 of x squared to the 4th. So we got that. And now I'm going to do the derivative of the inner function. So times negative sine, or excuse me, we got to take the derivative, the inverse of cosine. So that's going to be times 1 over square root of 1 minus x to the 4th, right? And then we got to take the derivative of x squared because that's our final inner function, so times 2x. So this is all going to be 10x times the inverse of cosine of x squared to the 4th power, all divided by negative square root of 1 minus x to the 4th. So once we do that, we'll see that our answer choice will be B. I'm going to quickly go through the last two because these are the more easy parts of the Unit 3. 3.5 is just about using the right derivatives, knowing which derivatives to use. So we're going to go through some questions. So I'm going to start off with a somewhat tricky, but it's kind of not half bad. You know you're going to have to use chain rule because our outer function is square root and our inner function is going to be 1 plus square root of x. And it just wants us to find the derivative. So what I'm going to do is I'm going to write this as a power because I know I'm going to have to use the power rule. So just do the power rule, 1/2 times 1 plus the square root of x to the negative 1/2, and then bring out 1 plus square root of x, take the derivative of that. The derivative of 1 is 0. The derivative of square root of x is just 1 over 2 root x. And then let's see where we continue from there. So 1 over 2 root 1 plus x times, 1 over 2 root x. So that's just going to be 1 over 4 root x plus 1 times root x. So that's just going to be square root of x plus 1 times square root of x. So yeah. So that's going to be option C, or option D. So for the final question for 3.5, it's going to be the derivative of ln 3x times 5 to the 2x. And I know it's going to be product rule because I have two functions being multiplied together. So I'm going to do that. So I'm just going to write it above right here. So I'm going to take the derivative of ln 3x. So that is just 3x or excuse me, 1 over 3x, and then I have to do chain rule, so times 3, or multiplied by 5 to the 2x, plus ln 3x, and then the derivative of this is going to be 5 to the 2x times ln 3 times 2. And when I do that, I'm going to multiply everything together. So this is just going to be 1 over x times 5 to the 2x. So 5 to the 2x all over x plus 2 ln 3x times, and this is meant to be ln 5 actually. So ln 5 times 5 to the 2x. And our answer is going to be A. And that's it for 3.5. And finally, 3.6. It's the last one. This is definitely the easiest one. It's just doing like the nth derivative, or like a certain number of derivatives. So we're going to do that. So we got this function, and it wants us to find the double or the second derivative. So when it comes to finding like certain derivatives, if we have just like one single line on top of the function, so like f prime, that means first derivative. So first, and then if we have 2, it'll be second derivative, and then when there's 3, it'll be third. Then after that, it'll be numbers. So this will be the fourth derivative, and so on. So how I'm going to solve this is turn everything into powers. So we got 3x to the 1/2 minus 32x to the -1. Find the first derivative by doing power rule. That's it. Nothing crazy. So I'm going to get 3 over 2 times the square root of x. So that's really it. Plus 32x to the -2. Or just 32 over x squared. That's our first derivative. So this is f prime. So we got to do f double prime. So we got our second derivative, and then we got to plug in 4. So this is just 3 over 2 x to the -1/2 plus 32x -2. Do power rule again. So -3 over 4 x to the -3 over 2 minus 64x cubed, and then this just becomes -3 over 4 times the square root of x cubed minus 64 over x cubed. So we got that down, and now we got to plug in 4. Let's do that. So -3 over, and this is not meant to be a 3. That's meant to be 2. So just ignore that. So square root of, so 4 cubed is just 64, and then that'll be -3 over 4 times 8. So we'll worry about that later. Minus 64 over 64, so just -1. So -3 over 4 times 8, so 32 minus 1, and then -3 over 32 minus 32 over 32 equals -35 over 32, which is our slope at x equals 4 for the double or the second derivative, and that's it. So for this one, it might look confusing because it's not asking for a specific derivative, but rather the nth derivative. So what the derivative is going to look like if we keep on deriving it. So I'll show you an example. So we got to take the derivative of x e to the x, and that's going to be product rule because x is its own function, e to the x is another function. So we got 1 times e to the x plus x times e to the x. and then you're just going to get e to the x plus x times e to the x. So that's the first derivative. Now we're going to do it again, and you're going to start seeing a pattern. And yeah, so e to the x plus 1 times e to the x plus x e to the x. So you're going to get 2e to the x plus x e to the x. And I'm going to do it one more time. So this is just going to still be 2e to the x. And then plus 1 e to the x plus x times e to the x, which is just 3e to the x plus x e to the x. So the pattern is that x e to the x is going to stay the same, and n e to the x, so like any number of n, is going to keep on increasing. And if I factor out an e to the x, and let's say n is like our number that's increasing, so n, and then factor out e to the x from this x, it's just going to be e to the x times n plus x. That's what our nth derivative, when we keep deriving it, is going to be. And as you can see, our answer choice C matches that. So that's going to be our final answer for this question. So that's really it. Unit 3 definitely is like a bit difficult, but if you just practice and memorize the rules, chain rule, how it works, and then the derivatives of the trigs and inverse, you're going to be fine. I wish you all the best for tomorrow's test.